So hello everyone, I am back and today we are going to solve problem number 64, minimum path sum. And let's just first copy this problem statement into our, so that's it. And let's just look at the problem. So we are given m into n grid filled with non-negative numbers greater than 0 or 0. And so like we have to find a path from top left to bottom right which minimizes the sum of all numbers along it. So we have to find the path which has the minimum cost. So so like for firstly what we need to do, we will initialize the dp array. We'll initialize the dp array 2D. It's going to be 2D grid right now. So so we will place infinity how much times? One more than row plus one. If there are two rows, then we must have like three rows. All right, but firstly this is about the column. This is about the column, right? This is about the column. And after that, what do we need to do for n? And this is going to be row plus one. Why row plus one? So that it can go from 0 to row. And if that's the case, we'll assume like if we have an array, I mean to an array 1 2 3 4 5 6 7 8 9, then we are trying to take extra positions 1 2 3 4 5 6 7. What these extra positions are for? Actually, we will be going from here, checking out the positions, and the we will be checking the right one and the bottom one and the right one. So like a kind of this right one and the bottom one, right one and the bottom one. And we'll be doing this for each of them. Firstly for this, then for this, then for this. Now we move one row up. Firstly for this, then for this, then for this, one row again, this. Now let me dry run this and show you how it works actually. Showing you this, you might know like you'd easily know that I'll be running two loops. One loop from for I, and that will run from 0 to rows, number of rows in grid. And second loop, rows in grid I mean in grid rows, or I can write it for j 0 to grid columns, and this will be j. Now what will I do? Please try to focus on this. Please try to I'm just going to say this. Okay, so we are going to calculate it by saying dp of I j equals to whatever was the path, like the cost from grid. We'll consider that because we'll be taking it at every point, plus this is going to be a very important part of our question, dynamic programming. Yeah. Okay, so right, what is right? dp of I plus this is bottom, right? I plus 1, this means one below and j at the same column, one below same column, bottom one. Second is going to be dp of I j plus 1. This is the right one. So this was the right one, this was the bottom one, and we have to calculate it every single point. At every single point we are going to calculate it. And Because of that, because of that, we'll be able to calculate our answer dynamically. So, and at the end, we are going to return what? Return this position TP of 0 comma 0. We are going to just return this. That's going to be ultimately our answer. So, like, firstly, if the example we have, and this like DP array we found. Let me make it again. Infinite, 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 infinite. This one more again. Yeah. Now one thing I forgot to tell you, that you're going to make either this or this as 0. So we are going to make this as 0. So we can just erase this and make it as make it as 0. We're going to erase this and make it as 0. So okay, what is going to be our, and I'll just write this equation here again so that you can refer to it every time we solve. dp of ij equals to grade of ij plus min of dpi plus 1j and dpi j plus 1. All right, so this is it pretty much. And for this dp of ij, grade, what's the position it predicts? 4 to 1, 4 to 1, it becomes 1 plus 1 plus minimum of this and this, it's 0, so it becomes 1. Okay, we start from here and we can now come here and we'll take what's this position? 2. 2 plus minimum of this and this, infinite and 1, minimum is 3. And now we come here, infinite, that's at this place it's 4. 4 plus minimum of 3, and infinite it's 4 plus 3, 7. 7. Fair enough. Now we move one row ahead, upwards, and we check what's the minimum, what's the like 1 is at this place. 1 plus minimum of 1 in infinite, this becomes 2. And again at this place it's 5. 5 plus minimum of 2 and 3, 7. All right, 7. And 7 comma 7, the minimum is 7. But what's at this place? 7 is already at this, there is 1 at this place, right? Yeah, 1 at this place. 1 plus minimum of 7 comma 7, 8. That's a big number among all of them. But we'll go ahead one row upwards. What's at this place? 1. 1 plus minimum of infinite 2, it's 3. Minimum of 7 and 3, 3. But what at this place? 3. 3 plus 3, 6. And minimum of 8 and 6, 6. But what's at this place? 1. So 6 plus 1, 7. What's going to be our answer? 7. Alright, we've solved this. Great. Now let's just go back to question and let's just write the code. I hope I don't make any mistakes. I make a lot of blunders writing code. Even though I've been lead coding since last 2 years. R comma C. Okay, no jokes on me. Yeah. So len of grid. C is len of grid. And now what we are going to do, we are going to initialize a DP array. It's going to be float of negative infinite, infinite, not negative infinite, into C plus 1 and another, that's because it's a 2D array, for dash in range r plus 1. All right, for I. Okay, we are also going to make the lowermost value as r c. Yeah, r minus 1 2, that's going to be 2. Like, yeah, r is 3. R is 3, so 3 and r minus 1, so it's 3. I'll just make it this as 3, and this is c minus 1, which means the column, the third column, 0 1 2. Yeah, we're doing it right. For I in range n, it's nothing as n. Okay, we have to start from the very bottommost position, so we are going to take it as r minus 1, right? Right. And this is going to be, and we are going to make it till minus 1, so that we go till towards 0. For j in range c minus 1 minus 1 minus 1. All right, dp. Okay, firstly it's grid, whatever is it, the grid call, we'll copy that. Grid ij plus minimum of dp I plus 1 j comma dp I j plus 1, one bottom and one at the right. So I think we're done here. Let's just return dp of 0 comma 0, and also we'll print dp array first to check if I'll just run this first to check if there are any errors. I hope there is not. Unmatched. Okay, I guess this is correct now. Solution list assignment index out of range, and we are going to just place this here. And check like what we are getting now. Accepted A, submit it again. So yeah, it's accepted.